Nope, you're going to participate. All right, so first of all, complex zeros and the fundamental theorem of algebra. Now we know a complex number is any number. So when it says complex zeros, that means any type of zero. Now 2 times ago, recall, we learned how we were dealing with rational zeros, rational roots. That means fraction and whole number roots. Today we're going to deal with those, but also imaginary and also irrational, because complex means any type of zero. So right here, do you guys see how I'm just giving you a bunch of examples? Any zero is a complex zero. Any type of zero. Doesn't matter if it's rational, irrational, imaginary, whole number, fraction. Now the fundamental theorem of algebra we already know. This is what the fundamental theorem of algebra says. The highest degree of the polynomial will be the number of solutions that polynomial has. So this one would have 5 solutions. If it says solve, you would not stop till you found all 5. Does that make sense? So this one would have 4 solutions, 30 solutions, 1 solution. That is literally the fundamental theorem of algebra. Highest degree is the number of solutions. Okay, so then we'll just get right into it and start right away. It says, find the zeros, and then what is the complete factorization of p of x? So notice 2 times ago it just said find the rational roots. This time we've just got to go all the way to the end no matter what. Because last time we stopped, if we got to a quadratic and it didn't factor, we were done. But today we got to go all the way because it wants any zero. So I would start by making a bucket of solutions. It really helps to kind of keep your stuff nice and pretty. And then it helps you not forget. So we know that we're going to have, based on the fundamental theorem of algebra, we should have 3 solutions. Do you agree? Now we're going to solve these the smartest way possible. We've learned all these methods to make our life easier, not harder. So if you look at this, what you could do is P over Q. I would not do that method because there are 4 terms and it happens to possibly factor by grouping. Let's try. And then if not, we would have to do P over Q. So I group, pull out the greatest common factor here, which would be x squared. So divide by x squared, then left is x minus 3. Pulling out a positive 1, and then left is x minus 3. So now you'd say, oh, x minus 3 are safe havens the same, therefore I can continue. I pull out my x minus 3, there it is. So then left is x squared plus 1. We've just factored it down to linear and quadratic, which is nice, because now we can set each of those equal to 0 and solve. X minus 3 equals 0, x squared plus 1 equals 0. So now I'll add 3, x equals 3 is a solution. Right here, don't do it in your head. Don't do it in your head. Subtract 1, x squared equals negative 1. Square root both sides. X is equal to, plus or minus I. So I would like you to write them out. X equals I, x equals negative I. Questions on that? Pretty easy, right? If you know what you're doing, that was not hard. Then from there, what you should say is, it says, then it wants the complete factorization. So technically, guys, if we have the solutions, even though we know this didn't factor, if it asks us to completely factor it, that means we need to get down to linear factors. If it's degree 3, there should be 3 linear factors. Now, because we have the solutions, we'll use those to get the factorization. If we have x equals 3 as a solution, wouldn't x minus 3 be the factor? Then what would be the factor here? Yep, x minus I, and then here, x plus I. And now there's our 3 linear factors. So yeah, even though it didn't technically factor, if I just said to you, factor, you would have stopped here, because this doesn't factor. But because it says complete factorization, you're going to go all the way. You have to use the zeros to get it. Otherwise, you couldn't factor it. Yes? I think both. Since it says find the zeros and then what's the complete factorization. So part A, part B, basically. Okay, let's do another one. Okay. So that one we had a factoring technique. So notice, same question, find the zeros and then completely factor it. But notice, it is not a quadratic. A lot of people look at this and they say it has the same form as a quadratic, so I just use the quadratic stuff. You can't use quadratic information unless it is quadratic, but it is indeed degree 3. So we are going to make our box of solutions. We know there are 3 solutions. Now from here, no factoring technique that we know can solve this because it's not a U substitution, it's not factoring by grouping, it's not quadratic, there are no ways to factor this. So we're going to have to use the method of P over Q. So leading coefficient Q, ending coefficient P, so then we would list out factors of P, plus or minus 1, plus or minus 2, plus or minus 4. Factors of q, plus or minus 1. So our factors of p over q, 1 divided by 1 is 1, 2 divided by 1 is 2, and 4. So there's not a whole ton here. So then on the test, what you'll do is just start testing. Now think about it. Once we find 1, we'll have a quadratic, and then we can solve by either quadratic formula or factoring. So from here, I'm going to test 1 and see if it works. Now making sure I notice that x squared, there are 0 x squareds. I got to put in my 0. So 1, 0, negative 2, 4. In fact, you know what I always have people do on the test when this kind of thing comes up? They go through and they're like, Miss Christensen. They come up and they're like, I swear to you, I've tested every single one of these. None of them work. And so what do I do? And I can't tell you because it's a test, but it's that you just forgot the 0. So yeah, none of them are working because you don't have the correct format. Does that make sense? Okay. Add straight down, multiply up, add straight down, multiply up, add straight down, multiply up. That one didn't work, did it? Okay, moving on. So you test negative 1. Same thing, 1, 0, negative 2, 4. Add straight down, multiply up. Add straight down, multiply up, add straight down. That one didn't work either. So then I'm going to try 2. 1, 0, negative 2, 4. Add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down. Still no. So we go on to negative 2. Not getting too discouraged because we're going pretty quick. 2, 1, 0, negative 2, 4. Add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down, and boom, we just found one. So we go to our bucket of solutions. X equals negative 2 was a solution. From there you should say I went from degree 3 to degree 1, degree 3 to degree 2, so this is x squared minus 2x plus 2 equals 0. Now in the last lesson, if this didn't factor, this would be our only rational root. But today we're finding all the zeros, so if it doesn't factor, quadratic formula. Well, multiplies to be 2 and adds up to be negative 2, nothing. So then we would quadratic formula that bad boy. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is equal to 2 plus or minus. This is 4 minus 8, isn't it? 4 minus 8 is negative 4 all over 2. So we have x is equal to 2 plus or minus 2i over 2. So isn't that x equals 1 plus or minus I? So I'd say x equals 1 plus I. Yes, I would split them up in your final bucket of solutions. X equals 1 minus I. Look, that makes sense. There's our 3 solutions. So now what we're going to do, watching the factors a little bit more carefully on this one, working backwards here. So annoying. This did not used to have issues, but I just can't complain because what do you do? Ay, 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 ay. Okay. All right. So let's write our factorization. For x minus 2, what factor would I have? X plus 2. Okay, now right here, it's just algebra, you guys. Use algebra to get this side equal to 0. Wouldn't I minus 1 minus I to both sides? So I have a x minus 1 minus I. Any confusion on why it's that? Okay, then let's look at this one. Minus 1 plus I, minus 1 plus I. So we have an x minus 1 plus I. There's our 3 factors. We've now factored it completely. All good? Okay, awesome. Couple more examples. Doing good. Okay, degree 5. So it says find the complete factorization and all 5 zeros of the polynomial. Well, first of all, guys, before you try to do anything, any method, you look to see if you can factor something. So if you notice well, I'm going to hurry and go like this. Okay, so we have 5 solutions total. Okay, let's go ahead and see what factoring technique, what can I pull out? Yeah, let's pull out an x, but even better, they all divide by 3. So that'll be better, won't it? If you pull out 3x, pull out 3x, divide by 3x, divide by 3x, divide by 3x. So then left is x to the 4th plus 8x squared plus 16 equals 0. Now from here, if you really so desired, you might be able to do P over Q, but there's a better method. Can anyone tell me if I want to keep factoring this? U substitution. Do you guys see how this is very similar to squared x constant? Degree 2, 1, constant. So can you tell me what my U substitution is? Good. U is x squared. So this is actually right here, this is now U squared plus 8U plus 16. So now we'll factor this. What multiplies to be 16 and adds up to be 8? 4 times 4? So I can quick factor, so this factors to be U plus 4, U plus 4. But then from there you'd say U's not really U is really x squared. So we have x squared plus 4, x squared plus 4 again. And then we won't forget about the original 3x. Is everybody good with that? Okay, so now from there, to find my solutions, I can set each of those equal to 0. So I have 3x equals 0. X squared plus 4 equals 0. X squared plus 4 equals 0. Solving for x. Divide by 3. 0 divided by 3 is 0. X equals 0. From here, we would subtract 4. X squared equals negative 4. Square root. X is equal to plus and minus 2i. Won't I get that same thing here again? So let's just write it out like this. So x is equal to 2i with multiplicity of 2. And x is equal to negative 2i with multiplicity of 2. 1, 2, 3, 4, 5. There are 5 solutions listed here. Questions on that? Okay, now let's write out the factorization here. I swear I waste 5 minutes at least trying to click on the right thing. Okay, let's write out the factors. There should be 5 of them. Do you agree? Okay, so there's an x minus 0, so just an x. I don't know why I put parentheses, not necessary, but whatever. I'm going to move on. That's fine. X, then I have a x minus 2i squared, right? Everyone, if there's a multiplicity of 2. And then we have an x plus 2i squared. And there it is factored. Okay, you guys are doing really good. I just want to make sure you've seen everything that you could possibly see for the homework. So, okay, winding down here. Okay, this is the last big one, so let's do this last one. Okay, find all 4 zeros of p of x is equal to 3x to the 4th minus 2x cubed minus x squared minus 12x minus 4. There are 5 terms here. We don't have a factoring technique for that. So we have to use, unfortunately, p over q. Here's q, here's p. So factors of p, plus or minus 1, plus or minus 2, plus or minus 4. Factors of q, plus or minus 1, plus or minus 3. So there's going to be kind of a lot here. Our factors of p over q, 1 over 1, 1/3. 2 over 1, 2/3. 4 over 1, 4/3. And then remember, we're all going to help and we're going to be super careful, because if we mess up, you might say yes or no to one that really works. Everybody agree to be very careful? Say, I agree. Okay. Okay, I'm going to take, let's start with the whole numbers. I'm going to take 1. Somebody take negative 1. Somebody do 2, negative 2. 4, negative 4. Everybody pick one, a different one, and then if you say, tell me if you figure out one that doesn't or does work. I'm going to just start with 1. Okay. So we had somebody else test negative 4 and they say it doesn't work. This is in my not box. Okay. Let's try. Okay, so let's see if 2 works. 2. Did I mess up? Okay, cool. So we just found when x equals 2. So x equals 2. Now, every step of the way, I checked my new polynomial once again to see if there's a factoring technique to help me continue. So we went from degree 4 down to degree 3. So this is 3x cubed plus 4x squared plus 7x plus 2. Now look, there is 4 terms, but if you try factoring by grouping, inside your parentheses, inside your safe haven's not the same. Therefore, factoring by grouping is not an option. Therefore, we must keep testing values. So now from here, though, you're going to want to test these new coefficients, everybody, not go back to the originals, because we want to go now from degree 3 down to degree 2. You have to do that. So, everybody, did anyone find any others that did or did not work? Nobody tested negative 2 then. What the heck are the other people doing? Okay, x equals negative 2 was a no. So we've tested, have we tested all the whole numbers then? Okay, x equals 4, it did not work. So guys, we have no choice but to go on to our fractions. But you guys, it actually usually multiplies out a lot prettier than you'd think. I gotta give myself some room to write. So let's start with, I'll start with positive 1/3. Be really careful, guys, when multiplying out. But you guys, they actually multiply out really quite nicely, actually, you'll see. Gotta give myself some room to write. I gotta keep my coefficients there, though. Okay, I'm doing 1/3. 3, 4, 7, 2. One-third definitely does not work. So I'll test negative 1/3. Guys, watch. It actually comes out nice and pretty. If I add 3 down, I get 3. What's 3 times negative 1/3? Guys, 3 times negative 1/3. Negative 1. Do you all agree? Add straight down, we get 3. What's 3 times negative 1/3? Negative 1. Add straight down, we get 6. 6 times negative 1/3. Negative 2. Add straight down, we get 0. So do you guys see how it was actually really easy, the multiplication? So then we go off to the side and say x equals negative 1/3 was the solution. And now we went to a degree 2, so we'll solve accordingly. So we have right here 3x squared plus 3x plus 6 equals 0. I'm going to pull out a 3 just to make my life easier. So then left is x squared plus x plus 2 equals 0. If this factors, great. If not, quadratic formula. It doesn't factor, so quadratic formula. So x equals negative b, so negative 1 plus or minus negative 1 plus or minus the square root of b squared, 1 squared minus 4 times a times c, all over 2 times a. Guys, why can I ignore the 3? Because what? You were saying it right. Yeah. So 3 right here, if I divide by 3, isn't that not going to matter? It doesn't have a variable on it, everybody. It's going to divide out at some point. So if you went back to here and did quadratic formula, it'll all work out the same answer. So then from there we have x is equal to negative 1 plus or minus. And then right here we have 1 minus 8. So that's the square root of negative 7 all over 2. So that would be x is equal to negative 1 plus or minus I root 7 over 2. I would split it up every time, and there's a reason. It makes rewriting it in its factored form a lot easier. Okay. Okay, don't go anymore. Don't go anymore. Okay, so watch what I do. X is equal to negative 1 plus I root 7 over 2. I got to write down here. X is equal to negative 1 minus I root 7 all over 2. And then it wanted us to factor it. So right here we have a x x minus 2. Right here we're going to have a, don't say x plus a third. That's not the correct way to do algebra to go backwards to get it equal to 0. Shouldn't we times by 3? Times by 3, then add 1. So wouldn't that be 3x plus 1? Now guys, this should all make sense to you. You should be able to click and say, oh, if that is the linear factor, it would make sense that negative a third is a solution. Are we good? Then don't let this freak you out. It's just like 2 extra steps. Get this equal to 0. So wouldn't I times up by 2? So right here I'm going to have 2 times x, 2x, and then that's gone. Then what would I do right here? Add 1. Then we would minus I root 7. That wasn't bad. So then down here, same idea. You would times by 2, so that'd be 2x. Add 1. Add I root 7. And now it's factored. So not too shabby, honestly. This lesson, I feel like it's just kind of takes a while to do some of the problems. Okay, so here is the conjugate root theorem, which we already know, guys. If you have an imaginary solution, its conjugate has to be a solution. If you have an irrational solution, its conjugate has to be a solution. Well, that makes sense, guys. These come from the quadratic formula. Doesn't the quadratic formula have a plus and minus? Then there is no plus without a minus. So therefore, once again, if you have an imaginary solution, you have to have its conjugate must be a solution. So if 2i is a solution, then negative 2i must be a solution. If x equals 1 plus 3i, then x equals 1 minus 3i, 1 plus 3i must be a solution, plus and minus. You guys see? You only change the sign in between. So if x equals root 2 is a solution, x equals negative root 2 is a solution. If x equals 1 plus root 2 is a solution, x equals 1 minus root 2 is a solution. Now I always have people have a hard time with, what if this would have been a negative? The conjugate would have still been negative 1. It's just a change of sign in the middle, in between. So on the test, this is actually going to be pretty easy. I don't think we need to test your abilities. Do you guys know how to do the conjugate? Like if I said to you, okay. Now that's only true with imaginary and irrational roots, not necessarily whole numbers or fractions. So right here it says, find a polynomial with rational coefficients. That means whole number or fractional coefficients, not imaginary. And then it says, that has these roots. So what you're going to do is you're going to work backwards. So you're going to say, okay, so x equals a half, and x also equals 3 minus I. Now without being told, you'd have to say x also equals 3 plus I. Don't be that person that says, oh, well, then negative 1/2 is also a solution. That's not true. So then we're going to work backwards, so we're going to do it the correct way. We're going to find the linear factors. So we need to go clear to standard form. We would times by 2, subtract 1. So we have a 2x minus 1. We have an x minus 3 plus I. We have a x minus 3 minus I. Everybody listen to the rule. If you're ever distributing out something like this and you have conjugate pairs, you always want to multiply the conjugate pairs together first, because a lot of things are going to end up canceling out. So you're always going to multiply conjugates together first and then multiply it in here. So watching very carefully, guys, we really should be able to do something of this caliber and not make errors. So watch. X times x is x squared. X times negative 3 is negative 3x. X times negative I is negative ix. Then because I've distributed x through to all three things, I cross it out. Negative 3 times x is negative 3x. Negative 3 times negative 3 plus 9. Negative 3 times negative I is plus 3i. Now I've distributed negative 3 through. So I times x is plus ix. Do you agree? I times negative 3 is negative 3i. I times negative I is negative I squared. Then what I would do from there is change any I squareds to be negative 1. So don't we have minus negative 1? That would become a plus 1. Okay, so now combine like terms. X squared, no other x squareds. Minus 3x, that's minus 6x's. Minus ix plus ix, plus 3i minus 3i. 9 plus 1 is 10. Everybody listen If you get to here and you still have ice, you have messed up. Absolutely every time. If you have ice, you've gone wrong. Start over. It will always come out to have all the ice cancel out. Everybody good with that? So then from here we have a 2x minus 1, and now we would distribute and combine like terms. But I don't think you need to see that part. Do you agree with me? Okay. Okay, I'm not going to go through this one, but I just want to see if you guys could understand the instructions so you don't get to the homework and get frozen. So it says factor P, this is P, factor P into linear and irreducible quadratic factors with real coefficients. Then factor it completely into linear factors with complex coefficients. So what do you think the first part's asking us to do? Yep, find all the, factor it down to just quadratic and linear stuff. But then from there, keep factoring it clear down to the full-on linear roots. Do you want me to do this one? Because some of you kind of look confused. This will take 2 seconds. So how would I factor this one? So this would be u equals x squared. So this would be u squared plus 2u minus 8. So then you multiplies to be negative 8, adds up to be 2, 6, no, not 6. 4 times 2, agreed? 4 times 2, negative 2. Can I quick factor? Yes. U plus 4, u minus 2. Therefore, this factors to be x squared plus 4, x squared minus 2. Everybody good? Do you guys see how we factored it down to quadratic factors? That is quadratic factors. Now from there, technically it doesn't factor anymore. But it says, then factor it to its linear factors with complex coefficients. So it's saying, yeah, now we do want you to factor it completely. Well, we can't factor this unless we know the solutions, and then we'll work backwards. So what would be my solutions here? X is equal to plus or minus 2i. Does everybody see? We did it in our head. We set it equal to 0. We subtracted 4, square rooted it. Then what would be my solutions here? X is equal to square root of 2. Okay, good. So then our factors will be x minus 2i, x plus 2i, x minus root 2, x plus root 2. And then those are the linear factors. So this is my last example of the day, right here. Same instructions, different problem. I just think that a lot of you would probably freeze right here. It's good to remember this one. Maybe write this one down for yourself. So we're going to factor it to quadratic factors, and then we'll factor it completely. So you're going to have to recognize that this is a u substitution problem, just like the last one, but a little different u substitution. So if I had this, x squared minus 64, I could factor this. So what is x to the 6th with an x squared involved? X cubed squared minus 64. Is this and this the same thing? Yeah. So what would be my u substitution? So u equals x cubed. So now we're dealing with u squared minus 64. So from here you would factor it. Well, multiplies to be negative 64 and adds up to be 0. 8 times negative 8. We can quick factor this quadratic to be u plus 8, u minus 8. Now u's not u. U is x cubed plus 8, x cubed minus 8. Now from here they will expect you to remember, if you have two perfect cubes, how to factor it. This is the front with the front, front with the back, back with the back. So from here we're not to quadratic yet, but once again, what the US should recognize, what they're hoping, and it's been a long time, we learned it in 1010. So this is two perfect cubes. If I cube root the front thing, I get x. If I cube root the back thing, I get 2. You don't do the sign. The signs come in later. Now we're going to do, I'm ignoring this for right now. Now we do the front times the front, x squared. Then the front times the back, 2x. Then the back times the back, 4. Then this sign and this sign are the same. This sign will be the same as the original. The next sign will always be opposite of that. The final sign will always be plus. Now let's move on to this piece. Changing to red. So we have this cube root the front thing, I get x. Cube root the back thing, I get 2. Don't do the signs yet. Front times the front times the back times the back, this sign and this sign are the same. The next sign will be opposite. The final sign is always a plus. And now do you guys see how we factored it down to quadratic and linear? Quadratic and linear stuff. Here's the thing. If you have two perfect cubes, you guys, two perfect cubes, the linear part, great. The quadratic part will always be imaginary solutions. So that would be our first answer, but then it wants us to factor it completely. So we're going to have to find the zeros. This one we don't need to find the zeros for, that's the factor. But this one we're going to have to solve. So we would have to do quadratic formula, x equals negative b. So it would be positive 2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So 2 plus or minus the square root of, I don't remember this one coming out that way, b squared. No, because then we end up back at the top. We're trying to factor it, right? We're pulling it apart. So now to factor this piece, I have to get the solutions because they don't factor. It doesn't factor. Does that make sense? So we have 4 minus 16, right? So wouldn't that be, yep, negative 12. No, this one came out different last hour. What did I mess up on? Maybe last hour I messed up. Is my quadratic formula looking right to everybody? Oh, wait. Yeah? Okay. So we get negative 12. I must have messed up last hour and just nobody caught it. So then we have 2 plus or minus, this would be 12, 2 times 2 times 3, so that'd be 2i root 3's all over 2. So that'd be x is equal to 1 plus or minus I root 3, right? Yes. So then my factors for that would be, we have an x plus 2, then we have a x minus 1 minus I root 3, and we also have an x minus 1 plus I root 3. So then we still have our x minus 2, and then we'd have to do quadratic formula for that one, which came out to be, I'll just tell you last hour, it came out to be, we did quadratic formula, we got x is equal to negative 1 plus or minus I. So then we would have a x plus 1 plus I, and we would have an x plus 1 minus I. Now count, isn't it degree 6? If it's degree 6, there are 6 solutions. If it's degree 6, there should be 6 factors when you go clear to the end. 1, 2, 3, 4, 5, 6 factors. That is so interesting. I'm trying to figure out what I've missed here or missed last hour, but oh well. The idea is what counts, I guess. Okay, that is honestly the end of the lesson, so you have the rest of the time to practice. I would skip 3-5, go to 3-6.